Welcome to the Carolina Weather Group. I am James Brierton. It is July the 19th, 2017. We're going to be talking rip current safeties on tonight's show, and we will bring in our guest from the National Weather Service in Charleston, Carl Barnes, in just a few minutes. But our panel this week, I am being joined by our friend Eric in Memphis, and we have Shay in Charleston, South Carolina, where if you are living along the coast, you know you got quite the round of afternoon storms. We had them here in Charlotte just yesterday. Matter of fact, if you live in this part of the Southeast and this part of the Piedmont, you know about this time yesterday is when two outflow boundaries kind of crossed paths and exploded over Charlotte. We had that severe thunderstorm warning that brought reports of up to inch-size hail in parts of Uptown. We had pea-size hail in other parts of the Mecklenburg area. We even had some water rescues going on in the Uptown area where some of the waterways, or excuse me, some of the roadways had been flooded. So it's been a very active summer. We've been getting plenty of those afternoon showers and thunderstorms. And let's go on down and check in with Shay Gibson, who got his own round of those afternoon showers and thunderstorms in the Charleston area today. And Shay, I understand the roadway is still a mess at this hour.
Yeah, we had quite a severe punch this afternoon. Storms coming down from the northwest towards the southeast. And they blew up over the Charleston area, especially over these urban heat island zones where you get this superheating. We had some pretty cool temperatures the last couple of days. Today we got hot again. Just ahead of these storms really allowed for an explosive feature. We had some hail, about $half size hail reported, and strong winds. Some of the hazards were 60 to 70 mile per hour winds. And we also had some construction tarping as part of a big project to sand and repaint the Don Holt Bridge in North Charleston. This tarping fell all over the road. It's very heavy, very high density tarping that fell all over the traffic as it was traveling underneath. Most of the cars managed to squeeze out from under it. They closed the bridge down. It's still closed now. I'm sure they're probably getting the contractors out there to try to deal with the situation. But James, do you have the live up on that? Or
so matter of fact, if you can pin me up real fast on Google Hangouts, and also if you're watching us tonight, not only on YouTube, but also on Facebook and on Periscope. This is video from earlier today, about 6:20 or so. This is the tarp that Shay was referring to that you can see down here on the roadway of Interstate 526. Certainly that made the evening rush quite a mess. I'm going to close this out. I'm going to pull up some live video. Bear with me here just a second because I want to show you at this hour what is happening. We are looking now at the on-ramp of the bridge, and your eyes are not deceiving you. That is traffic actually now turned around, coming down the bridge the wrong direction, because these are all the folks who were just near the site of the actual tarp collapse and have now been given permission to exit the roadway by making a U-turn. And what they are actually, Shay, looks like they are exiting up a up-ramp. So we saw just a few moments ago some heavy construction equipment now heading up to the scene, and hopefully they'll have this cleared up and ready to go, hopefully in time for the morning commute.
Yep. No injuries reported as of yet. I think everybody's okay. Definitely a safety concern, especially in high winds. There was hail on the bridge as people were sitting in traffic. But I think for the most part, besides a few accidents, I'm not sure if there was a fire out where I live near Wando. I did hear a lot of fire trucks right during that storm. So we'll wait to see what the news says about it later. I'm sure there's going to be a lot of reports of several things, trees maybe down. We'll look for the local storm report for the National Weather Service. Charleston as well, with Carl Barnes is with us tonight. We'll get to him in just a moment. I think we wanted to get over to first real quick, the Charleston weather the next few days. Hot, very hot. We're looking at upper 90s for tomorrow. We could hit 100 degrees. That's slightly suggested by the GFS model from this morning, but the heat indices with a little bit of drier air may not bring it up to the hazard levels or the advisory levels, which is 110 degrees under a heat index for at least 2 hours. So we'll wait to see what happens there. We're going to stay hot through the weekend with a chance of afternoon thunderstorms tomorrow, and maybe not so much Saturday and Sunday as things sort of dry out under that heat. And we'll go over to you, Eric Procius in Memphis, Tennessee.
Hey there. You sure that wasn't contraflow from Tropical Storm Don there coming back off the bridge? That sure looked like what you see when a hurricane is getting ready to make landfall, and it does look like we're still pinned there on James. So it's been we had quite a wet summer up until about a week ago, and the faucet shut off, and the heat built, and we're getting underneath that mid-level ridge. The Death Ridge that's over the central part of the country is sliding east. We had our hottest day of the year today so far, 97, and first heat index, heat advisory for the Memphis area was out today, first one for this year. So heat indices were up around 105 here. It's been dry for the last week or so. Everything has been really, really green well into the summer here, but it's some of the plants that need water once a week are starting to show signs of starting to get a little dried out already. That ridge is going to sit over us for the next couple of days, kind of slide off to the east. So it does look like we're going to stay hot for the next few days. Looking like temperatures will be pretty close to what they were today, 97, heat indices around 105 in the afternoon, maybe a couple degrees warmer until about Saturday. Then it looks like that ridge will break down. We'll get some troughing up to the north and help to push a couple of upper level disturbances move through. Maybe we'll finally break out of this for a little bit and get a chance to get some rain around here again by this weekend. But it's definitely summer has shown its force here as we move into mid-July. So that's what's going on over here on the west side of the viewing area.
All right. Thank you, Eric. Tonight's guest is Carl Barnes of the U.S. National Weather Service, Charleston, South Carolina. He is going to be talking to us tonight about rip current safety. They have a new product out that they're going to be using soon, and we're looking forward to seeing that. But we all know how dangerous the rip currents can be at the beach, especially in the surf zones. Basically, wherever you see surfers lined up near sandbars around here in the Charleston area, you know that that's probably a likely zone where you would see rip currents. And the tidal swing of 6 feet doesn't help any at all here either. But each piece of coastline along the southeast region, or most of the coastal United States, has its own unique set of values for rip current forecasting. We're going to get Carl to talk a little bit about that tonight. If you want to go ahead and introduce yourself, Carl.
Yeah, thanks, Shay. Really appreciate you guys having me on. Because you mentioned Carl Barnes with the National Weather Service here in Charleston. Been here for about 3 years now and been heavily involved with the Rip Current program. Also, in high school and college, I guess I spent a total of 4 summers lifeguarding at the beach, between beach up in Virginia on the Chesapeake Bay and then moving down to the Outer Banks. So kind of have a lot of firsthand experience with rip currents, as well as understanding of how now we try to factor everything from the nearshore weather to the offshore incoming swells into making the best forecast possible. And it's still within the realm of the Weather Service, a very young science, and something that's an initiative that's only really been pushed for the last couple of years, because we were seeing, year in, year out, there were just rip current fatalities kind of along all stretches of coast, including the Great Lakes. So it's something that's really been pushed, because really it is pretty much entirely weather related in terms of the swell coming in and all that. So I think we are the best organization to handle the rip current forecast. So I look forward to talking to you all tonight about it, and something I'm personally really passionate about. And I know, Shay, you spend a lot of time down by the water too. So look forward to talking about it.
Okay, so we are going to, James, are you on? Did you want to ask anything or have anything to add before we get started on the topic?
Yeah, Carl, I just want to kind of, I guess, start off the topic by bringing folks who maybe live more inland or who have been a little bit more distant from the shore recently up to speed on the continued danger of rip currents. And what's immediately coming to mind for me is the video that made the rounds maybe 2 weeks ago now of the family who were stuck in some waters off a shoreline, and folks actually made a human chain to go out and rescue them. And I was just, that's what comes to mind as we begin tonight's conversation. And I'm just wondering, from your perspective, when you are meeting with people and talking with people and trying to share with them how to be proactive about rip currents, how do you convey the danger to them?
Yeah, so that's really a lot of layers to that, getting into more of the social science side of things. And that's obviously something that is very important, and probably something that we have a lot of room for improvement on. But as you kind of hit on, reaching people inland who are coming to the beach in the summertime is just as important as reaching people who live here within our current forecast area. So we have a Rip Current Awareness Week that we typically do right at the beginning of summer. Mostly we're sharing information on social media. We're getting our inland offices to reshare that information. So that's kind of the big step at the beginning of the summer that we're doing to try to spread that information inland. But then, kind of multiple approaches that have all proved pretty successful, but nothing obviously has been 100% successful. But now a lot of beaches you go to, you'll see pretty much on every dune walkover, you'll see it's become pretty famous, but it's basically a diagram of what to do if you get caught in a rip current. Swim parallel to shore, like swim out around the rip current. So just, kind of taking your time and taking your surroundings as you're going to the beach is important, because you want to check out that sign and just kind of get the tips. Obviously, knowing the rip current forecast before you go is a good idea. And you mentioned kind of human chain. The one thing that we want to stress above everything else is swim at a lifeguarded beach. Do your research and find a guarded beach. I know here in our area, we cover everything from basically the Charleston County beaches, which would be like Isle of Palms, Folly Beach, beaches that are popular for locals as well as people really across the Southeast, all the way down to Tybee Island, which is Savannah, Georgia's beach. And we have everything from basically very minimally developed beaches with no lifeguards that are very rugged, wouldn't have quick access to any kind of emergency personnel, to pretty heavily developed and actively guarded beaches like Isle of Palms, like Folly Beach. So the biggest thing we can stress is swim at one of those lifeguarded beaches. Do your research before you get to the beach. Your chances of drowning at a lifeguarded beach is 1 in, I think it's something like 1 in 30 million or something. I mean, it's just almost never happens to see a drowning at a lifeguarded beach. That human chain incident is a perfect example. If they were at a lifeguarded beach, they wouldn't have had to form that human chain, because there would have been lifeguards there. They have the flotation buoys, they have the paddle boards, they have the equipment that they would have been able to go out and get those people who were stuck in the rip current. So I don't know the exact situation with that, but obviously there weren't lifeguards there that required all the other beach patrons to take that kind of action. So that's the one thing to really stress.
How did somebody go about, if I'm heading to the beach this weekend, how do I go about researching what the rip currents are going to be at my destination?
Yeah, so best thing I can tell you is weather.gov/beach. Very easy to remember, weather.gov/beach, and that'll take you to a national map. From there, you can click down and kind of zoom in on whatever area you're going into, and continue to zoom in to an actual, like a beach-specific forecast. So, for example, if you're going to Wrightsville Beach in North Carolina, you can zoom all the way in on Wrightsville Beach, click on the little umbrella, and it'll give you the rip current forecast for Wrightsville Beach. Right now, we do a rip current forecast just 1 day ahead of time. So we currently have the rip current forecast out for tomorrow. We don't really do a forecast beyond that, but that is something that we're working on. Yeah, there you go. That's weather.gov/beach right there. So you can kind of zoom in, and then those umbrellas are kind of central on the warning areas. So it's Jacksonville's right there. You can continue to click down. Yep, Jacksonville Beach area, and it'll give you everything you need to know. It'll give you your chance of thunderstorms, which is very important on the beach because lightning strikes are comparatively common on the beaches. It'll give you your UV index, your rip current risk, a lot of good information, and it's really easily accessible.
What goes into preparing a forecast like that?
Right. So we're looking at the vast majority of what we look at are meteorological factors. Probably the single biggest thing is swell. If you don't have swell, you're probably not going to get significant rip currents. The other large factor that we look at is the nearshore wind direction. So even without swell, if you have an onshore wind, you can still get rip currents. They're usually relatively weaker, but just because there's not a large breaking wave certainly does not mean that there's not rip currents. So those are the two big things that we look at. We get the swell from the generally the Global Wave Watch model, and then we have another model that in the nearshore environment brings it into much higher resolution. We use our own wind forecast for it, which we do produce out to 7 days. And we also look at other things like Shay mentioned here along the southeast coast. We have very large tidal ranges. So Charleston all the way down to Savannah, we're generally looking at 5 to 6, sometimes higher foot tidal ranges. So those when those tidal ranges are higher, increases the risk of rip currents just because you have more water moving in and out at the beaches. We're also looking at other factors like, is it a weekend? Is it a holiday? Are there going to be a lot more people at the beach? While that might not necessarily influence the actual rip currents themselves, it does play a role in terms of, if there's more people on the beach, it's probably going to necessitate a higher risk. And finally, we're looking at the kind of the specific beach shape, and if there's anything like a pier or a groin. What those do is they build up sandbars in specific locations, cause breaking waves in those locations, and that repetitive breaking wave in the same location generally is able to kind of put a cut in the sandbar, which is what you're looking for when you're looking for rip currents.
That sounds like it takes a lot of local knowledge about the areas and what to expect and how the waterways work. I know there are a lot of layers to the National Weather Service. These forecasts that are coming up, they're being done by the local forecast office, the folks who are essentially in the backyard of these beaches?
Yeah, and that's absolutely right. We're doing the local forecasting here, and the person or the people that we rely on the most heavily for reports of rip currents are our local lifeguards. We call all of our local lifeguards twice a day to get basically a report of what conditions are like at the beach. There's no good, affordable observing system for observing actual wave height at the beach, and you certainly can't, as far as I know of, there's no way to automatically observe whether or not there's rip currents. You really have to have human reports of rip currents to know that it's occurring. So we're calling our lifeguards twice a day all the way. Again, we're calling Charleston County all the way down to Savannah. I know Wilmington's calling Wrightsville Beach. They're calling all their lifeguarded beaches. Jacksonville, I know, is doing the same. They're calling all of their guarded beaches multiple times a day and getting those reports. And then we use that to kind of calibrate the forecast that we're putting out.
Yeah, I remember having wave height instrumentation on Isle of Palms Pier at one point, the Folly Beach Pier at another point. And you could actually get some wave heights there. But that equipment does cost a lot to maintain. And so those have kind of gone to the wayside. We only rely on offshore buoys to give us a majority of the data that we get along the coastline in our cool shelf waters. The question is how do you decipher what kind of swell height you're getting from these buoys by the time they make it to the beach? Obviously, Folly Beach, you can tell there's a physical difference between Folly Beach and Isle of Palms. Folly Beach will get a bigger swell than Isle of Palms. So how do you determine which beaches are going to be the most dangerous, or do you just sort of do a general swath of the whole area?
Yeah, so we do zonal forecasts. So it is a forecast for a zone. Obviously, somewhere like locally, somewhere, say, Kiawah Beach, where you have the beach on the northern tip basically faces south. The beach on the southern part of the island faces basically directly east. So, we can only get but so specific, but we do have a pretty good idea of what's going on. Let me screen share. So we have, like I mentioned, we have the Global Wave Watch 3 model, which will show, basically it shows how the swells out in the open ocean are leading to, or how those are being generated. And then we have a higher resolution model that kind of shows how those swells, when they come into our local area, how well they're actually going to filter into the beach. And so we'll rely pretty heavily on that because that's hard to say otherwise. But yeah, I mean, one beach to the next, even within one beach, you will have different wave heights at different locations. I know like with Folly Beach, the washout sticks out just a little bit further, has the groins, which help focus the wave action. So because of that, the washout is a very popular place for surfers. And hopefully I don't get in trouble for just,
No. I mean, we all know
locations, but yeah, I don't think it's
the edge of the world there. Everybody knows that's the spot to go for surfing.
Exactly. And that's, you go further up into North Carolina, Cape Hatteras, they obviously can get more swell than other places. Well, the reason for that is twofold. They stick out further and they have a narrower continental shelf. So that's for between buoys. So for Charleston, we have the Edisto buoy, which is basically 60 miles southeast of Charleston, 40, 60, somewhere like that. 60, I think it is. No, 40. I don't recall, but it's in that zone. And so we're getting the swells that are making it into the buoy, but then the swells are actually deteriorating before they reach land because of our shallow continental shelf. So we're looking at swell height and swell period. The period doesn't change much due to the shallow shallower water of the continental shelf, but the swell height does. So we do factor in that decay from what's being observed at the buoy to what we would actually expect at the beach.
Interesting. Yeah, I do love the product that you have. I think just sort of posted that a few months ago, and I love that swell chart. Let me back up just a second here, Carl. Real quick for our viewers, what exactly is a rip current? We want to kind of get to the definition of what is a rip current. Is it different from just a regular current? We had something in the news recently where kiteboarders pulled some people out of the water off a sandbar at Sullivan's Island, which there's no lifeguard zones here, by the way. A fairly dangerous area, but that was not a rip current zone. That was just a high current zone with eddying off the tip of that sandbar. So explain to the viewers what a rip current is and how it may differ from other things going on in our surf zones.
Yeah, thanks for that question. That is something that is very important and is often misunderstood. So you'll often hear the misnomer of an undertow, but there's really no type of current that would occur at our beaches or really any beaches across the United States that would pull you downwards. Most currents are vertical currents, and because of that, we stress to people that it's not pulling you down. As long as you don't panic, you're going to continue to float, even though and definitely don't, if you have flotation, don't ditch it. Hold on to it, because you're not going to get pulled under the water. You're just going to get generally pulled out away from shore. So try to totally remove undertow from your vocabulary. It's a misnomer, and it's very misleading about what it actually is. The other two that are commonly used are rip currents and rip tides. And those are used interchangeably, but they're really not interchangeable. So we'll get rip tides is kind of not quite as official of a term as rip currents, but it's still generally, especially around inlets or areas like you talked about with Sullivan's Island, where you actually have dry sandbars, and you'll have as the tides fill in and go back out, you'll have water obviously entering or leaving different waterways, and like I said, especially around inlets, you'll have really strong currents that are completely independent from any kind of swell or wave action. It's simply caused solely due to tides, and those can be very dangerous too. We had, unfortunately, a drowning on Fripp Island down in southern South Carolina near Hilton Head in early June, and it was very near an inlet, and kind of got the report of it. Got a report of it being an undertow, which obviously we kind of were able to immediately eliminate and say, all right, it didn't pull them under. We need to do some research and see what it actually was. And in working with Beaufort County, it's been determined that it was most likely rip tides because they were swimming so close to an inlet. It was more tidally based. And that day there wasn't much swell. Rip currents are what we forecast. Those are the things that really vary day to day. Rip tides are generally going to be fairly consistent day to day because you do have that tidal action with only minor changes from one day to the next. Rip currents are basically, you have to have a breaking wave to have a rip current. Waves in the open ocean have no net transport of energy until they get into shallow water and they break. And when you see that white water, what that is actually energy being transported by the wave. And so as the wave's breaking close to shore, energy is being pushed into shore. And so that wave breaks over shallow sandbars. Well, with that energy going into shore, in order to stay in equilibrium, equal everything out, you have to have energy coming back out away from the shoreline. And that is what the rip current is the rip current is basically that water that has been forced into the shore by the breaking waves, looking for a way to escape back out toward the open ocean. And so those rip currents most commonly form in basically what we call trenches, or deeper parts of the sandbar, or between sandbars, where there's not as many waves breaking in toward the coast, where the actual the water and the wave energy, or the water and the net energy, can come back out through that gap in the sandbar. So because of that, when you go to the beach, you want to look for areas where the waves are breaking. Even though that would appear to probably be more dangerous, it's actually safer because you don't have the threat for rip currents when you're actually on the sandbar, or at least you have much less of a threat of rip currents. If there's somewhere where you see waves breaking all along the beach and there's one gap where the waves aren't breaking, can seem at first glance like that would be the place you want to swim, but it's actually more likely that that's where rip currents would form. And so the actual water current is probably going to be pushing out toward the ocean in that location.
That's really some great information. I didn't know that about the waves, and I was going to get into another question, but I'm going to table that for a moment. What I want to ask you is, you mentioned look for where the waves are breaking. Look for those signs, the educational signs that have gone up at a lot of beaches. The thing I also wanted to ask is, if I get to the beach and I have forgotten to go to weather.gov/beach, should I be looking for like a flag or something that might give me some indication if there are excessive rip currents that day? I think a lot of people might be familiar with the ones that go up for like a tropical system.
Yeah. Well, fortunately, our website's optimized for mobile, so you'd still be able to check it. But
okay, well, but too.
Yeah, but no cell phone signal. We'll go with that. Yeah. So unfortunately, that's something that varies a lot beach to beach. Even just within our area, different beaches use different techniques for alerting patrons to what kind of rip current risk there is. In Charleston County, they will never do anything below a yellow flag. So they'll always be yellow flag for a moderate risk, basically red flag for high risk, and then they have a purple flag for sea life, which would be jellyfish or the guys in the gray suits or something like that. And so they never go below a yellow flag. Well, we have other beaches that will go down to a green flag on a day where the water is pretty calm. So there is definitely inconsistency from one beach to the next and how they communicate that message. So I guess really understanding the beach that you're going to, and again, do your research the night before you're headed to the beach, or even that morning. Hop on. As far as I'm aware of, every beach has a website with some kind of a link to just a general beach safety page where they would be able to tell you what means what.
Checking the UV, checking the thunderstorms, checking the rip currents, putting the checklist together in my head. So the question I tabled was actually going to be one I wanted to bring Eric in on, because I was going to acknowledge I grew up on an island, so I kind of always had rip currents in the back of my mind, although I did not know the part about the waves, so that's good information. I know Shay lives along the shoreline, spends a lot of time at the beach. Eric, you are kind of our guy who is on today's show and is a bit more inland than everyone else. So not to ask you to speak for the mass population of or Memphis or all inland communities, but what type of impression do you get from folks who maybe live a little bit further away from the shore? Do you think this is something that is top of their mind when they do vacation to the beach? Or is this something that collectively might need additional education?
No, that's actually a really good question. We're in an area where the Gulf Coast is a favorite vacation spot around here, and so a lot of folks will go to Orange Beach, Pensacola, Gulf Shores area. It's a pretty easy drive down there, and I would say probably that not being exposed to it at all here inland, that most folks don't know when they go down there exactly, what they should be watching for, especially these signs that you've been talking about. I'm learning a lot here. We know that the double red flag is, a time you're not supposed to be out there, and we kind of follow the locals. And usually those tourist spots, they're pretty good about kind of publicizing as you get onto the beach over the pier or, whatever, that what the conditions are. But no, we don't have a good understanding of necessarily even what rip currents are. I would think there's a lot more, for those who live closer to the beach and are going, consistently during the summer and so forth, they'd have a better understanding. So this is all good stuff. We don't get rip currents on the Mississippi River, so it's not something we have flags flying down at the foot of Beale Street here in Memphis to warn us of. But we definitely do have a lot of folks that go down to Gulf Shores. So I'm assuming then that I saw from the website, I took a look at the beach website, that there's forecasts that are done for the Pensacola area and down into South Alabama. I guess the question I would have is, as far as general frequency, so the meteorological conditions that are required, certainly swell and so forth is one of those. I would think that the Gulf beaches probably maybe don't get quite the frequency of the rip currents that the Atlantic beaches do, just because we don't have the fetch over the open Atlantic that is coming in. Is that do you know if that's a true statement, or is it people just as susceptible on the Gulf beaches as they are on the Atlantic?
Yeah, I definitely have a good idea for that. First, I'll just hit on something you said and piggyback on it is, especially people coming from inland, when you are going to the beach, it's a big deal. You're typically at least using one full day to do it. In most cases, you're using multiple days. You paid money. And so what we find is, and this makes perfect sense, I'd probably do the same thing too. But when you're on vacation, the last thing you want to do is stress. Last thing you want to do is think about safety. And so a lot of times people let their guard down, and that's something else that we need to, again, the social science side of things, where we need to figure out, all right, what's the best way to let people know that they need to be paying attention to the potential for rip currents without creating any kind of burden or doing something that they're going to be resistant to because we're vibing them, we're giving them bad vibes on their vacation or something like that, So it's finding that balance is really important. But yeah, so your actual question in terms of locations that are more susceptible to rip currents. In general, the Gulf would be less susceptible because just in terms of the surface winds needed to generate that swell, larger swells equal a higher rip current risk. It's not as frequent in the Gulf, especially during the summertime. Outside of a tropical cyclone in the summertime, it's very, very rare to get any kind of significant swell on the beaches. In the wintertime, when you might be able to get a low or some, even just some gales or something like that could generate some swells. But climatologically speaking, the Gulf would be probably less likely than anywhere on the East Coast to get swells and rip currents. Doesn't mean it's not going to happen, obviously, is the disclaimer. And one thing that we have to be aware of as well is that not everyone has an idea of how, people understand generally sensible weather, what they get every day, afternoon thunderstorms, or hot and humid in the summertime, so on. And something that's not as intuitive is the generation of swell, how it's created and how it travels through the water. So, when you're seeing waves break on the beach of any size, that's generated from a really bad storm somewhere really far away. And this carries over into so many other aspects of meteorology. If it's not happening where I am, it's not affecting me. The very sad situation with the flash flooding out in Arizona, it wasn't raining where they were, so why would they have to worry about flash flooding? And it's the exact same thing with swells. You can have a really significant storm off the beach, it still creates a hazard at the beach because of the swells that travel through the water. And so kind of portraying that and portraying just because you went to the beach yesterday and it was calm and placid doesn't mean today's still going to be calm and placid. It varies day to day based on what's going on off the shore.
Yeah, the only follow-up I have to your initial comments there is, when people are going to vacation down there from an area like this, there's a finite time frame that they're going to have down there. If you're living close to the beach and you got rip currents, well, I'll just go tomorrow. When you spend a couple $100 a night and you've got 3 days and then you have to go back to Memphis, people are going to naturally perhaps take more chances. This is the only chance I've got. And, you don't want to go down there and have 3 days that are totally rained out or totally cold, like it was when I went down to Gulf Shores in March this year on spring break, and it was freezing the whole time. We had our jackets on, the wind was blowing, and I'm sure the rip currents were bad, but I didn't get my toes in the water to find out. So anyway, yeah, that's another one of those kind of societal factors that plays into the whole thing as well. So.
Yep, and speaking from experience, being a ocean rescue lifeguard, like you mentioned, some days they'll put up the double red flags, which generally means no swims allowed in the water, or even some places just one red flag means the same thing. For the lifeguards, they don't want to do that. Those are the hardest days that they can have because they're constantly going up and down the beach, informing people, telling them to stay out of the water, having to watch people. They would much prefer to just let everyone go in the water. So it's not like they're doing that to pick on you or anything like that. They only will do that if it really is a serious hazard.
So Carl, we talked about some of the onshore winds that would help to aid or to generate rip currents in general. So for our area, like Charleston, for instance, we have our southerly sea breezes that happen regularly, and they vary from mild to strong. Mm-hmm. They generate some ground swell, but it takes a little while for those. The other direction of wind that's a real big concern is the northeast wedge, which drives a fairly larger, consistently larger swell down the coast with a stronger current overall. If you want to sort of elaborate on which direction of winds outside of large storm events in the ocean, which direction of winds for the local rip current safety aspects do you think should be the pretty much the most important to talk about?
Okay, yeah. So probably in general, those directly onshore southeast sea breeze type winds are what we have observed more rip currents and have gotten reports of more rip currents with. I'm not going to say that's a hard and fast rule that those are more dangerous though. I think it's at least partially because those northeast wedges happen more often in the cool season when no one's in the water to begin with, or the lifeguards are, depending on the beach, generally, the usual Memorial Day to Labor Day is when the lifeguards are on the beach every day. And you just don't get many wedges in that time frame. One thing of note is those northeast winds here and along the southeast coast. Those are alongshore winds, or basically parallel to the coast. And those do actually, while they can be kind of hazardous in their own right, they actually work they work against strong rip currents from forming, because very similar to how a thunderstorm going vertically in a highly sheared environment can kind of get sheared off. Very similar thing on those northeast winds, where your longshore will keep your rip current from directing straight out, and it'll actually, the parallel to shore winds will cause such a strong longshore current that it'll push you kind of into the rip current and then right back out of the rip current if it's strong enough before you get a chance to be sucked out. And that's why, even though when you're at the beach and you have those winds that are parallel to shore, like the northeast winds, you get in the water and you can tell there's a really strong current. You get in and you play for 5 minutes, and before you know it, you can't even see your towel anymore. That's, it's an inconvenience, but in terms of safety, that's a lot less hazardous when you have that strong longshore current than it is when you have strong rip currents, because one will pull you out to deeper water, the other one will generally keep you about the same depth of water and just push you down the beach.
Very interesting. So we talk about forecasting, and you have a new product that you wanted to introduce tonight. Would you like to do a screen share? And if you have any other presentation materials you want to pop up on the screen and just sort of go with it, that's totally fine with us. I think we've covered the basics, and yeah, I'm looking forward to seeing this product that you guys have come out with. Is this just for Charleston, or is it for the entire East Coast?
So this is actually going to be for the entire country is the plan. And again, getting the observations is very challenging. You have to have basically eyes on the ocean to get those observations. We don't have any way of automating the observations. So what we're doing this summer is getting as many observations as we can to try to calibrate this model. So we have this NWPS, the Nearshore Wave Prediction System. That's a newer model, which I can show you actually. Flip over to this one. So this is kind of a look at significant wave height, but you can see this is a pretty high resolution model. Just for an idea here, this would be the Charleston Harbor. This area up here is Cape Romaine. So it does a pretty good job of kind of understanding how the swell deteriorates as it gets closer to shore, understanding a lot of those near shore effects that we weren't able to model in really high resolution previously. Well, now as part of this model, they're working on also automating a rip current prediction. So that would be based on what we already talked about, because this model does swell height. It uses our forecast winds. It understands tidal effects, and it would be able to automatically take all that into account. So this current summer, we're working on getting a whole bunch of observations. So hopefully we can calibrate it over the winter and maybe begin to use it experimentally next summer. But we do have other offices. So the office in Wakefield, Virginia, which covers like Virginia Beach, Northern Outer Banks, and up to the Delmarva Peninsula, they're currently running it. And so just to kind of give you an idea of what the output from it looks like, this would be somewhere just south of Virginia Beach, but basically drops a point on the beach I think it's every like 2 or so kilometers. So it's very high spatial resolution on the beach. Whereas, like I said, currently we're doing just kind of a regional forecast. This would actually be able to, for a specific location on the beach, give you a rip current risk. And we can see for this location that it actually gives you a trend. So it I believe gives a risk every hour or two, whereas again, currently we're doing one risk for the whole day. So there's plenty of room for improvement, and this is a great step in doing it. So this would be somewhere just south of Virginia Beach. Looking at, based on the model, they're looking at kind of mostly a low risk. But then you can see as we get into, well, sorry, I guess this is actually old data. This is, again, experimental, so it's still kind of in the works, including the interface to view it on. But this is from back in early June, but you can kind of see what the output would be like, where you'd get basically every hour or two, you'd get a rip current risk for that period, and then you could see the trend. These kind of waves in the trend are tidally based. So your rip current risk for any given beach is going to be different at low tide, at high tide, depending on the incoming or outgoing tide. So this gives us a much higher spatial and temporal resolution and much more accurate model, and also takes it out beyond what we're currently doing one day. This actually takes it out essentially 5 days. So this is a complete game changer in terms of, from this you can actually see, hey, this day I'd probably be okay to go in the morning because it's a pretty low risk in the morning, but then we're going to see that risk jumping up pretty quickly in the evening. And that's information that we're just not conveying right now. So this is a really, really exciting, huge improvement to the way that we forecast rip currents. It's got, again, it's experimental. It's still being fine-tuned, but hopefully we'll begin locally receiving this data this summer 2018, and then being able to utilize it, see how valuable it is, and implement this to give people just a much more accurate and much more high resolution forecast of what they can expect at the beaches.
Hey, Carl, that's I was going to ask. That's a 6-day period there. It looks like I'm sure it's probably based on a medium range, WaveWatch 3 model blend.
Yeah, so it's this NWPS, this nearshore wave prediction system, is what it is. Let me see if I can. Yeah, here, this is perfect. So you can see for our area, we have this domain right here that I'm outlining with the mouse. This is our NWPS domain. So it takes, for all of these outer edges of the domain, it takes the data from the WaveWatch 3, which is comparatively a much lower resolution model, and takes that as its initial conditions and its conditions for the edge of the domain, and then takes into account very high resolution bathymetry data and tidal data, and really tailors that to, like I showed here, to a much more high resolution near shore wave model. So that's, I guess, its very most basic roots. It is using WaveWatch 3, but it's actually using this high resolution wave forecast from the NWPS for swell.
That's really neat. I really like that graph. I don't know if you can pull that back up again.
Absolutely.
I love how it has all of the information there. Your height through period.
Yeah. So this one would be significant wave height, and not surprisingly, as the significant wave height increases, that rip current risk is increasing. The period is here. It's actually generally staying somewhat steady, mostly in that 8 to 9 second. But then here we have a little more shorter period, which would correlate to just a local wind swell coming in. Direction also plays an important role in rip current formation. And then WL, I believe, is the water depth. So what this is essentially a representation of the tidal levels.
I wonder if that has the ET surge information in it. That's pretty neat. But
yeah.
The other question I want to ask, looking at this product, do you think in the future that this would be able to be spot forecast up and down the coastline? Say if I want to go to Fripp Island versus Charleston, would I be able to click on a spot at Fripp Island and get the forecast there individually?
Oh, absolutely. So when I wasn't zoomed in enough before, but when I zoom in, you can actually see each one of these gray dots here correlates to a location where there's a forecast for. So each one of these, it's calculating that rip current risk by the day. So here we can go up to like the oceanfront of Virginia Beach region, and you can get one for, if you're familiar with Virginia Beach, you can get one for kind of this main strand of the beach, and then you can get another one for just across the inlet at the Croatan Sound. I mean, it's that high resolution. Now, this is always kind of something that we get into with meteorology is high resolution is not directly correlated to a higher confidence forecast. Kind of similar to with the HRRR or the NAM. They're higher resolution, but that doesn't mean they're higher confidence than the GFS is in any certain solution. And it would be the same thing for this rip current forecast. But in locations where you have a pretty complicated beach shape, this could be very, very advantageous.
Absolutely, and it looks like those buoys, it depends on the density of the buoy readings and the data as far as the confidence level, I would imagine. So when you have all those spots extrapolating from nearby spots, I'm sure that a place like that in Virginia Beach, probably a higher confidence area than Charleston, maybe.
Yeah, absolutely. Virginia Beach has almost their entire beach has lifeguards, so they're getting what the Wakefield office would be getting would be very, very thorough reports from their lifeguards. Here, like for the Charleston beaches, like I said, Folly, Isle of Palms, we're getting those reports. We'll factor that into the model, so it'll be calibrated for those. Sullivan's doesn't have lifeguards. Somewhere like Fripp doesn't have lifeguards. So it's not going to be as well calibrated for those beaches, but it'll still be better than what we currently have.
Very cool. I like this new product. I can't wait to use it. Is this something that is available for the public to use right now, even in experimental mode, or is this something that you're keeping internal for now?
So it will be, to my knowledge, it will be externally available. Here we can scroll up and see that they have some areas up here that have a little higher risk currently. But they should be something that the data will still be released experimentally once we start running it. To my knowledge, that'll be available with obviously the caveat that it's experimental. It won't be exactly what we use for our official forecast, but we will look at it and compare it to what our official forecast would give us the way we currently do it, and use that to kind of validate the information from the model. So it should be, again, hopefully next summer, it should be available for the public to view the experimental output.
Carl, I'm curious, you mentioned earlier that you yourself were a lifeguard. What would have been different for you? What would have been the significance of having data like this when you were patrolling the beach?
So yeah, in terms of, I mean, there's again multiple layers to the utility of it. It could be just like with so many first responders or emergency responders, knowing that you have days coming up where you have a higher rip current risk will allow you to increase your staffing to account for it. Days where you have a lower risk, you might be able to reduce staffing a little bit, or you might be able to even use those days for training for the busier days. Again, so we fall under the Department of Commerce. So everything we're doing, at least in some aspect, takes into account not only public safety, but the economic utility of any of these models that we are developing. So something like that, where you can really align your resources for those times where you have higher risk, which is not at all dissimilar to all the other forecasts we do for emergency managers and county first responders, where we need to alert them on days where they have a higher risk of having to respond to weather-related incidents. But beyond that, in the immediate near term, nothing replaces being on the beach and having eyes on the water. This is still an outlook, and I think because of that, the lifeguards will still get the final say in what generally what the risk is at the beach and what color flag they raise. So just because we have a moderate risk out, the lifeguards might actually be seeing something different at the beach, and they might put up the red flag or the double red flag. So it's worth noting that even though we put out this outlook, still the lifeguards are the experts. They are the people who are responsible for all the patrons on the beach. So listen to them above anyone else.
Carl, one last question from me. Can you have a rip current with strong offshore winds and a large swell?
Oh, absolutely. Yes. Yeah. That swell is the most important thing. If anytime you have swell, you're going to have rip currents. You can just default to it. If we have a hurricane that's within our swell window, you can almost bet that at some point we're going to have some form of elevated rip current risk, regardless of the local wind direction. Now it could be, the local winds could act to make that rip current risk even higher. But yeah, the swell above all else is the most important thing.
Jogging my memory, I think you surf. Do you still surf?
I do, yeah.
And have you ever experienced rip current out on the water yourself, either swimming or surfing?
Oh yeah, absolutely, all the time. So with this rip current risk, one caveat is there's rip currents out there pretty much every day. They're just usually anytime there's a breaking wave, there has to be a rip current just to move that water back out toward the open ocean. But that doesn't mean don't go in the water ever, because typically when the waves are smaller, those rip currents are so weak that anyone can pretty easily escape them with any kind of swimming ability. So yeah, obviously as the waves get bigger, that's the time when you want to be in the water on a surfboard. And so yeah, we've seen some really strong rip currents. Say kind of anecdotally, the Outer Banks of North Carolina is much more prone to rip currents for a number of reasons. They get larger swell with that shallower or the narrower continental shelf. They also have, and this is very hard for us to predict and to factor in, but they have a totally different sand composition up there. They have much larger sand grains, which allows their sandbars to shift more, and they'll go from very shallow to much deeper troughs. So there's a lot of things that factor into that. But yeah, especially up on the Outer Banks, I've seen some incredibly strong rip currents. Even here, especially around groins at the washout, anytime there's waves, there's at least some weak or stronger rip currents at the washout.
Right. Just bear with me. I'm just showing some typical rip currents and some dye tracking that's been done. Have we done any of this dye tracking in the Charleston area?
No, unfortunately, our water is a little too brown for it. So it'd be very challenging to see it. But I think that first image with the light green dye, I think I would have to double check on that, but I think that one's from Kill Devil Hills, North Carolina. I know that they've done a number of they've filmed a bunch of rip current safety videos and worked really closely with the Kill Devil Hills Ocean Rescue up there, and they've done some visualizations like this up there. So I'm not 100% sure, but I think that one is actually an East Coast wave. A lot of the other ones that are up on the screen there, you can see different rocks or reefs mixed in there, and so those obviously aren't East Coast. Here we have just the general sand bottom beach, so we don't usually see the rip currents forming in the exact same location every day, like they would in somewhere like that where there's reefs.
Right. Yeah. There's different rip currents everywhere around the world. I remember I said on the show one time we had someone from National Weather Service Miami in, and I remember getting caught in a rip current in Costa Rica swimming. I was body surfing. It pulled me pretty far out. It got to a point where people on the beach were gathering. The only thing I knew to do was just lay on my back and do some backstroke kind of parallel to the shore and wait for the next big set to come in and ride it in. But it was pretty scary because you're out there. There's no one out there. And, that's the question. What do you do when you're trapped in a rip current? And that was my immediate education on it, was to go with the current, go side shore, be patient and calm, and wait for the opportunity to get back in. So what are your thoughts on that?
No, that's exactly right. So the thing that for years and years we've been preaching is when you are caught in a rip current, swim parallel to shore. And that's ideal. If you can do that, swim parallel to shore till you feel that you're well out of the rip current, not till you're just on the edge of the rip current, because then you could easily get caught back into it. But swim parallel to shore till you're well out of the rip current, and then swim back into shore. In recent years, we've actually kind of been stressing exactly what you said. Floating, just floating is the main thing. It's not going to pull you under. if you have flotation, a boogie board or something like that, we see all the time where people will get caught in a rip current. They'll try to kick back in against it. They'll say, oh, I can't kick against it. So they just ditch the boogie board and try to swim against it. And that is absolutely not the right thing to do. Hold on to that flotation. And, if you're not making any progress against the rip current, you can either try to swim, again, parallel to shore, keeping the flotation, or you can really just onshore, you can wave your hands and yell. That's it. At the very most basic level, it's not pulling you under. Float, wave, and yell. Those are the things. As long as there's someone else on the beach, they'll see it and they'll call 911. I'm not aware of any beaches that don't have some kind of, even if they don't have lifeguards, that don't have some kind of emergency response where they can get jet skis, they can get firefighters out there into the water very quickly to help pull you back in. So it's, at the most basic level, float, wave, yell, those three things. And then if you have the energy, if you feel comfortable, swim parallel to shore and then swim back in. But really just the float, wave, yell is the thing to stress.
Carl, that is some great information. I'm sorry. I think I just stepped on somebody. Was that you, Carl, or was that you, Shay?
So I was actually just going to do a quick screen share, and I think this might even be from the same thing that Shay was just showing. But it's a video, and again, I believe this was actually filmed here on the East Coast. Is that showing up right now? Yeah, there we go.
Yep, we got you.
Yeah, so this is a really good visualization of what the rip current looks like. Again, you have the white water from the waves breaking on the sandbar, and the rip current's going to be somewhere that actually looks calmer because there's not the white water right there. But that's exactly where the current is pulling out toward the open ocean. So that's where you want to try to avoid swimming in. And again, I think that this was filmed in on the Outer Banks. So this is actually exactly what it would look like on the East Coast. In terms of, you can just see it perfectly. The waves are breaking everywhere except that location, and that's where you don't want to be. You want to play in the white water.
I think I need to reprogram my brain. I think it was always avoid the big waves.
Yeah,
but that might be being in the waves, like you said, is the better place to be.
Yeah, well, yeah, exactly. And the waves can still be dangerous, but in terms of just focusing on rip currents, the waves are the place to be, man. Stay on those sandbars, stay where it's shallow, and you'll have a good time.
Yeah, absolutely. That's good. That's good context as well too. Always be alert when you're at the beach. Hopefully, somebody learned a little something new on tonight's show. I think each one of us did, and hopefully folks at home did as well, as they may be venturing to the shoreline real soon. So, Carl, I appreciate that. We're going to come back around to you in just a moment. We want to get your social information, social media information, so folks who are listening to tonight's podcast at a later date can maybe reach out, ask you a question, ask a question of your colleagues there at the U.S. National Weather Service there in Charleston. As we introduce a new segment that we started, I believe, just a week or so ago, it's time for us to go around the group to do our tweets of the week. Carl, no pressure, but if you've got something that comes to mind, weather related or otherwise, you are welcome to share it. I suppose if no one objects, I will start off with some tweets that I sent out yesterday. So these could be tweets that we saw or tweets that we sent, but these are some drone photos I took as a severe thunderstorm was approaching me in South Charlotte yesterday. Let me put these up for our folks who are watching online tonight on Facebook and on Periscope, and I'm going to do a screen share for the folks who may be joining us on. How am I going to do this? Here we go. For the folks who are on YouTube tonight using our other system. Here we go. So this was taken at about 380 feet above where I live in South Charlotte, so just within that legal limit. Looking back north towards the city, you can see a couple of those rain shafts. Kind of hard to make out, but there is the skyline there on the horizon. And you can see the leading edge of that storm yesterday as it rolled on through. And as we talked about at the top of the storm, top of the show, it did bring some heavy rain, hail, and really strong wind gusts at times too, and quite the light show, I will add. So, Eric, I see you are off mute. I will take that as a sign that you've got a tweet you want to show us.
I do, and thanks to Carl for being on again tonight. Very informative presentation for us, so thanks a lot. Learned a lot. Let's see if I can get to my tweet here. This is one that I saw that was shared, I think by Rick Smith. I saw it coming out of Oklahoma City on Saturday, and this is a severe thunderstorm that moved through the Oklahoma City area, and I'm going to go ahead and blow this up and let this run. So that looks like something you might see on the coastline. but this is well inland where you can't buy a shoreline view. Severe thunderstorm. I guess the winds are about 65 miles an hour, and there goes the garbage cans blowing down the street. So pretty nice southern plain storm there moving through the Oklahoma City area on Saturday. And that is my tweet of the week.
That's almost the kind you want to put on a trench coat and get on a skateboard.
Just watch out for the flying trash cans.
Exactly. Well, my tweet of the week, let's see. Let me do my screen share. This is from Charleston Today. This comes from Kevin Verbiage. I think it's Verbruge, maybe is how it's pronounced. The thunderstorms that were approaching the coastline today, he got a really, really good shot of a shelf cloud that has some really nice wall structure to it as well. It shows a very strong frontal boundary along this storm. Probably some very strong winds behind it, some hail built up inland. But if we look at the next picture, we see the progression of it. This is out by Edisto Island, and you can just see the definition of this shelf cloud. This is actually in a stage where it's starting to break down. It actually sort of fizzled out by the time it got to the coast. The storm exhausted itself. The sea breeze met it at the immediate coast, and so they only got a little bit of rain, maybe a little bit of lightning, but nothing as wild as what happened inland. The other tweet I have, this is really, really cool, and we're really starting to see more and more from the GOES 16 satellite. And this is from James Spann retweet, the information from Chris Veldon of SSEC, Wisconsin-Madison, and from SIMS. And you can see the high definition of these storms in South Dakota from earlier today from this storm system, and just incredible resolution from the GOES 16. This is going to be so much fun to use and very, very much of a learning experience for all of us. We're going to be learning a lot of new things from this, and you can just see how much cloud structure is going on in and around this storm system. Very impressive. So that one got my attention. Really took my attention away from what I was doing at the time. I was like, wow, that is just incredible. So we continue to see more and more from the GOES 16. I'm hearing that it will start to become operational in some levels as soon as this fall. So we're already seeing some really good positive things from it in the tropics. And I think it's going into AWIPS 2 already, isn't it, Carl? Or is that official yet?
Yeah, so it's definitely been pulled into AWIPS. It is currently experimental, and then like you said, it goes operational this fall. There is still a few things that they're working on with it. They have the GLM, the Global Lightning Napper product, which is going to be pretty revolutionary in terms of just a constant, really, really accurate idea of how the evolution of lightning is with thunderstorms, really high resolution. I think that's one of the last things that they're kind of really finalizing, and that's expected to be out within the next couple of weeks. And then after that, I think they're going to be pretty good to go operational with it. So it really is just incredible how much higher resolution it is. We have a number of research projects that we're currently working on to see already how we can utilize it.
For sure. I think James has one more thing he's trying to show us here before we sign off.
I'm going to sneak in one more relevant tweet from today. We talked about this at the top of the show, and Shay, I saw you retweet this during the show, and I wanted to share it out with our folks as well, too. We talked about that wind event that came through Charleston, South Carolina earlier today and left that construction tarp on the interstate. Here is a look at that moments before it actually fell onto the roadway surface itself. Probably one of the last few motorists to make it through here. Quite a scary and dangerous situation. And Shay, I think this speaks to what you were talking about, having driven that road multiple times yourself. You kind of thought this could be a problem if winds really start to pick up. So this is just an incredible view here from this motorist.
That's crazy.
Yeah. I mean, a friend of mine posted on Facebook about it. Is this some kind of haunted house? And I'm thinking, wow, that's a haunted house gone bad right there. That's definitely a learning experience for whoever put that up. And it seems like we're always learning something new about our bridges, especially like winter events and then this. And so we'll see what they do about it. Hopefully they'll come up with a better solution, something that maybe pieces of the bridge at a time versus the entire thing being enshrouded. So we'll see what they do. I'm interested to find out myself. So back to you, James. We'll go ahead and wrap up the show.
Yeah, let's bring in Carl one last time. Carl, thank you again for joining us. Lots of important information on tonight's show. How can folks reach out to you on social media, and do you have a tweet that you wanted to share with us?
Yeah. Oh, I actually do. I'll share a tweet with you.
All right.
Let me put on a screen share real quick. So we got this is from this is from a couple of days ago. We did not. It's not actually by us, but it is It is a video that was submitted to us, but this is sub-severe winds. This was on Lake Moultrie. So just wait, it'll pan back around to the left. But this was about 40-mile-an-hour winds. But it just goes to show, you can see that everyone's having kind of trouble wrangling that boat in, but it goes to show how quickly, especially on the lakes and on the waterways, things can really take a turn for the worse. You can see when we pan back around. I mean, it almost looks like ocean waves out there.
Wow.
They gave up on trying to dock and they're headed back out, but that's about
out there.
That's about 40-mile-an-hour winds right there on the lake, and that's Lakes Moultrie and Marion here, two very large lakes, and conditions can go south really quickly on those. So this was one of the more impressive videos we've ever seen. It looks like the ocean, but it's just a lake.
That's incredible. So 40-mile-per-hour winds. Do you recall from the time if for any reason this storm had a warning with it, or?
Yeah, it did not have a warning. It had a special weather statement out for
Sure.
it. So it was probably in the range of like 40 to 50-mile-an-hour winds, and our severe criteria is 58. So it was weaker than a technical severe storm. But yeah, we definitely, whenever we see something like that, we'll put out a special weather statement for the lakes, because for this exact reason, sub quote severe can still be very significant for them.
Yeah, I mean, I think that video speaks two fronts. A, pay attention to those special weather statements. And B, I know we've talked about it on the show before, folks get so used to seeing severe thunderstorm warnings that they may come to not give them much acknowledgement as they should. And looking at that video, it's a good reminder that that's a scary situation. And if you see a severe thunderstorm warning, it's going to be even more serious than what we just saw there. So certainly a good reminder. I appreciate you sharing that video with us, Carl. How can folks reach out to you on social media?
Absolutely. So our Twitter is at NWS Charleston SC, all one word. And our Facebook is facebook.com/NWS Charleston SC. So those are two ones. But really, since we cover people in a large area, just very important, very easy to find your local office's social media information. Follow your local office. We talked earlier about, we did the Rip Current Awareness Week earlier where we were putting out posts, but we were having all inland offices share those posts. So, really our one weather service, even though we have the offices that allow for some local expertise, we still work very closely in between offices to share information that we find is important to everyone.
Absolutely. So whether you live in Savannah or Charlotte or Memphis or someplace else, if you're heading to the beach, it's weather.gov/beach is where we can get the forecast we talked about today. Is that right?
That is correct.
Absolutely. Great information there, Carl. Thank you very much again for your time, and to everyone at home joining us either on tonight's live show every Wednesday night at 8 o'clock Eastern time, or, of course, you can find our podcast on iTunes and Google Play. Let's take a look at the schedule that's coming up in the next few weeks here. So next week, July 26th, we will have Mike of Mike's Weather Page on. I know we were looking forward to that conversation and revisiting the tropics as we make our way through the summer season. We will get to know Nash Severe Weather on August the 9th. And then August the 23rd, we're going to talk about journalism and live television and reporting from disaster zones. We'll have some friends from the Weather Channel joining us, including Reynolds Wolf. So some great shows continuing to come your way here from the Carolina Weather Group coming out the rest of this summer. And, of course, you can find us anytime at carolinaweathergroup.com and on Facebook, Twitter, and all your favorite social media platforms. I think we're going to put Shay in front in charge of a Pinterest board. What do you guys think? Get Shay posting some recipes or something?
I could just do tropics on Pinterest. How about that?
Yeah, there we go. So thanks again for joining us on behalf of our guests and our entire panel. I'm James Brierton, and we'll see you back here next week.